Okay. Hope you guys able to see my screen now.
Yes.
Yes.
Okay. So what I'm trying to give as part of this session is that before getting into the cloud as a terminology, as a technology, as well as why we are actually looking as a cloud offerings today. I'm not referencing anything with respect to Microsoft Azure only, so I'm referring in general concepts. But today, let's just understand the requirement and what exactly been running before cloud comes into the market. Okay, and then we'll see what exactly make the customer choose over the legacy data centers, right, against the cloud as a priority. Yeah. So in this scenario, like for most of you folks, it might be looks as a basic, but I just want to give these terminologies kind of data center basics. The data center is nothing but where the physical hardware resides for your enterprise organizations, and enterprise terminology will call it as a data center, right? Hope you guys have heard of this name. What is mean by data center? Where your physical hardware that can comprises of your compute, CPU, memory, as well as a network and a storage. These are all three typical core components of your data center, right? So I just want to give an understanding how the data center looks like, right? So in a typical scenario, you don't have any kind of a role or a responsibility to deal with this data center operations, but it is to make you understand if someone is talking about a data center, you need to visualize how it looks like, right? If someone is saying a data center, it is not possible that every one of us get an opportunity to visit a data center physically, correct? Everybody, we have worked through remote only, correct? We'll take a remote of this servers or a hardware and we'll do the administration, troubleshooting and management of the system. But it's typically really difficult to get an opportunity to go and deal with the physical data center operations. But when it comes to cloud, these terminologies will really do helpful for you guys to easily correlate and understand the concepts. That's where before getting into the cloud concept, I thought of to giving you a very basic understand how the data center look like. This is the data center I'm just showcasing you. It's a very small data center, whereas you could see, right, a data center as well as racks. Whatever you are seeing as a vertical ones, we'll call it as a racks. Whatever you are calling, you could see that in empty spaces, you could you could name them as where you could see where you could place your physical hardware. Already some of the areas you could see it's been filled up, right? That is nothing but your physical hardware. It can be a compute, CPU memory, it can be a storage, it can be a network switch. Okay, so what is my agenda is that to guys, if I'm saying data center, you could able to visualize. If I say a rack, you should know how the rack look like. The vertical ones, right, with the 44 units in size, we'll call it as a rack, right? Inside it, you will be having physical hardware. On top of a hardware, you will be running an operating system. That can be a Windows, that can be a Linux, that can be virtualized. We'll talk about subsequently. This is the front view, how it looks like. I'm just taking one among the physical hardware, how exactly it looks like in the rear view, right? So you could see that here in the rear view, there is a Ethernet cables. Every one of us is quite familiar with this, what you will be using for internet in today's scenario. Like older scenario will be using this Ethernet ports, and nowadays it will be kind of a fabric fiber connectivity. You could see that fabric ports and fabric connectivity as well. Apart from that, you could able to identify some kind of a fans which will be running inside of your hardware. Around 9 different fans is running to omit the hardware which is generating by your hardware, omit to the outside. So that's where you will air conditioning in a data center plays very crucial role, right? If you doesn't have an air conditioning properly been set up at your uh, data center, what will happen? You cannot have your hardware will be up and running. So that is one of the prerequisite. Okay, and you could see the different kinds of power supplies, and on a downside, around 6 different types of power supplies is available. Why they are maintaining 6 different power supplies here? Half of the power supply will come from one source, another half of the things will come from a different source, right? So that whenever something went wrong with one of the source, like if the issue with the transformer, at least other service will continue to give from a generator, right? Don't get confused. Don't get things like why these things been discussing, right? It is not you guys not gonna work on this area or a technology. It is only for the sake of understanding. If I say the power cables, if I say the network cables, if I say the fans which is running, so I just need you guys to visualize how it looked like. That is the only intention here. Clear?
Yeah.
And I just want to show you how the one physical hardware look like. Like this is one among the rack server, which is HP Brilliant DL380 Generation 7. So this hardware make and model will get differ based on the vendor and the capacity and the compute capacity. So this is HP. It's a Brilliant servers will be make and model. It will be horizontally very long, where you could look like this. This is how, and you can insert this physical hardware in your rack server, right? Typically, this is how your storage device. This is also look like kind of a rack, very bigger disk, which will be entire hardware will be consisting of your physical disk. What will happen? Your storage administrator will connect to the storage device and then manages it. Correct? For your environment. Whenever you need SQL Server requires some SAN storage as a LUN as a storage or a shared value. So we'll be taking care. Your storage admin will be assigning the LUNs or a storage disk to your servers. So typically where it is coming from in a data center, one storage device, physical device, he will logically combine this all the disk storage and assign it to your requirement. Clear? And then this is how your network switch look like. This make and model will get differ based on the vendor and the brand of it. So here the example is a Hansen is a brand. You have a Cisco, Juniper, L5. So there's so many vendors out there in the market with a different model and make. But Ethernet ports, these ports how it look like, it will never change. The number of ports, design will get changed. The ports how it look like, it will be the same. This is the network switches. This is what responsible communicating your hardware between each other as well as with the outside world. Till now it's clear guys how the data center look like, what is mean by rack, how it look like, how the rack server will be, and how the storage box, and similarly how the network switch and physically in a data center. I just want to give an understanding till here. Any questions?
Mm.
No.
No.
Okay. Now let's talk about, so let me use this tool draw.io, so where you can do the online diagrams. So this is an AZT27 data center. So click on create. Okay. Now, what I'm gonna do now is that give an understanding. So now you know how the data center look like, how the physical hardware look like. Now let's talk about once you have an hardware availability, how your application is delivering to the end users, what are the different typical components is comes into the picture, what exactly the legacy data center is playing in the older days, how the virtualized technology is taken over the market from a virtualization to cloud, how it's been migrating today, we'll discuss as part of this slide. Okay.
Okay.
So if you see now, assume that this is your physical hardware. So assume that in a real-time scenario, your physical hardware will be huge amount of a capacity, is not like our own personal CPUs, right? When they're purchasing the hardware in a data center that has very good amount of CPUs and memory. So I'm just taking very basic a compute that is 120 core CPU as well as let's say 512 GB of a RAM. So on top of this physical hardware, what typically we do? An organization, what typically they do? They will install the operating system, correct? It can be a Windows, it can be a Linux operating system. Till now it's clear, guys. It's similar to your physical laptop, similar to your CPU which you have been holding, whereas you will be installing an operating system of Windows or Linux operating system. Is it clear?
Yes.
Now, so on top of this operating system, what will happen typically? What we will do? On top of operating system, what we do? We'll install the runtime, right? What is this runtime? The best example is Venkat, like for example, you want to host a web server. So what is the prerequisite you need to install to run one website? I'm just taking one of the web server as my assume that as my required application to be delivered, or else Chiranjeev, you can name it like if I want to install Oracle DB in my operating system, on top of my operating system, I want to use an Oracle database as a service. What I need to install as a software?
Sorry, is a question to me or?
Yes, yes, yeah. So for
Okay.
you and Venkat, so what I'm expecting is that, so you have an exposure. So Venkat has disconnected. Sorry, I didn't notice that. That is fine. So Chinju, what I'm trying to get an answer from you is that, so if at all you want to install Oracle database or
Mm-hmm.
any Oracle product when it comes, so
Mm-hmm.
you want to install in a particular product or configure, you might be having some sort of a set of files, correct, which you need to
Yes, a metadata
install
file.
as a installable file. You need to install it, and then on top of it you typically run the DB, correct, or typically run the service.
Mm-hmm.
So that's
Yes.
what I'm trying to reiterate here. You'll be having an operating system. On top of it, let's say if I want to use very basic thing as an example to follow for Shiva and Harsha as well. If I want to use today MS PowerPoint or as MS Word or an MS Excel, what I need to install to use those services? I should have MS Office installed, correct?
It's a software bundle, right? The
Yeah, it's a
software
software.
bundle you need to have. Yeah.
Yeah. So if I want to use this, I need to install and configure. Otherwise, my system will not recognize any kind of a Word file or a PowerPoint files, correct? Similarly, if I want to run a website on my operating system, what I need to install? If it's a Linux server, if it's a Windows machine, you need to install IIS, Internet Information Services. If it's a Linux machine, you need to install Apache Tomcat to run your web server, correct? So on top of it again, what typically you will be having? You will be having any kind of a middleware. If at all your application is require some kind of a middleware, what Venkat is telling, right? He will be working for the middleware like JBoss, web servers and other stuff. So the middleware will come sometimes into picture, or you will bring in your own data as a code to deploy and run on top of this IIS or Apache Tomcat. On top of it, your application will typically run, right? So I'm just placing that after the data middleware, your application will be running. And then on top of it, your end user will access the application. Access the application. Till now, it's clear what we have just trying to understand here. It is a very basic flow, right? For any hardware. If you just take an example of our own data center or our own laptop as a desktop, this is a typical flow, right?
Yes.
Right. And next thing is, and to run one application, do you really think that it is going to use this 128 cores and 512 GB of RAM all the time?
No, it depends actually. It depends on the application what you are going to use for.
That's
We need to come. Yeah, we need to come up with the system requirement based on the application we are going to
hmm,
install on the server.
yeah. So why I was specific to this question is about what this is. We'll call it as a legacy, right? This is now it become a legacy data centers, whereas you've been typically dealing with in this particular manner. So when it comes to modern data center, what they have done, once after the physical hardware in between the operating system of Windows and Linux, they have brought in the layer of virtualization. Have you guys heard of this virtualization as a technology? Right? So I hope like you guys might have came across this from Oracle. Chiranjeev, we have Oracle VirtualBox. From VMware, we have VMware Workstation,
Yes. It's,
VMware Fusion. What typically these products will do?
see, we get like an option of what is it, choosing our own CPUs, memories. We get this free hand because when it comes to physical hardware, we have that limitations. Wherein virtual machine, based on the requirement, we can add or upscale or downscale the resources as we need.
That's correct. So Sivan, Harsha, have you guys ever used this VMware Workstations or Oracle box in your laptops to run on multiple operating system on top of single hardware? That's fine. So what happened on a modern data center when it comes, they have introduced a technology called virtualization. So when it comes to virtualization, you might have heard of the company called VMware, product name called Hyper-V, product name called Citrix. Chiranjeevi, you definitely might have come across these terminologies. Yeah, right. What this typically this virtualization platform will do.
Yes, yeah.
Yeah, so instead of here, as you mentioned, there is a tight bonding or correlation from a physical hardware to the operating system to break that limitation, right? Instead of having a limitation of a kind of a hard coding to the operating system of available compute resources, virtualization came into the market that does taken the control. I could say that it will breaks the hard connectivity between your operating system and a physical hardware and take the complete control. And it does help you to install and run multiple operating systems on top of a single hardware. So in this scenario, what we have done on a legacy data centers, we typically hardly run only one operating system on top of one physical hardware. Here, same hardware capacity, 128 cores and 512 GB of RAM. With the virtualization technology, what I typically do, I can run multiple operating systems on top of a single hardware. Right? How I typically do? like this. Right? So this is my operating system. I can have multiple operating systems here. So as space constraint, I just mentioned only 4 operating systems here. So all these are all operating systems. It can be a Windows. This operating system can be a Linux. This operating system, it can be in Ubuntu. This operating system can be an Oracle Linux also. Oracle also has their own flavor Linux operating system, right?
Right.
It can be a Mac operating system. You name it, any operating system you can run. But typically, what is your physical hardware in this scenario? It has
Uh,
your one physical hardware.
CentOS is
Sorry,
operating. CentOS,
CentOS,
one of the operating system.
CentOS. Is that correct you are referring?
Yes, that's right.
Okay, fine. So like that, you can name it any of the operating systems, still you could able to run on top of a single hardware. And also, as Chiranjeev, you have been mentioned, that is absolutely correct that whereas we could define the compute based on our own requirement. Let's say I'm having 128 cores and 512 GB of RAM. So what I typically do now, I can assign, right, the like the compute as, let's say, 2 core or 2 CPUs, as well as, let's say, 4 GB of a RAM to this operating system, right? In this CentOS, I could assign that is a production. I assume that is a critical. I am assigning 8 cores and giving it here as 64 GB. And the Ubuntu VM is test VM. I could give only, let's say, only 1 core and 4 GB of a RAM. And my Linux operating system, it can be anything. It can be Red Hat, whatever you name it. This one, assume that I am assigning 16 cores or 16 CPUs and then 128 GB of RAM, right? Typically. So like this, you have this one physical compute that 128 cores and 512 GB of RAM that can logically can be segregated and assigned to multiple operating systems. On a layman language and an understanding, what is mean by virtualization? It will allow you to create multiple operating systems on top of a single hardware. That is nothing but virtualization. A technical definition, virtualization will break the hard connectivity between your operating system and a physical hardware. Is that clear, guys? What
Yes.
virtualization will does? When it comes to virtualization, there is separate roles like VMware administrator, Citrix administrator, Hyper-V administrator. What typically these guys will do? Their responsibility is managing this physical hardware using this virtualization products and then create and run multiple operating systems. As we are creating this multiple operating systems on top of a single hardware, this technical terminology will call it as a virtual machine. What we'll call it as?
Virtual machine.
I were calling as a virtual here. Typically, this is not a physical VMs, correct?
Yes.
This is virtual. It means you're not directly embedded to the hardware. In between, you have a layer called virtualization. That's why on a technical terminology, what we call them? Virtual machines. Clear, guys?
Yes.
Right? On top of it, again, all layers will be same. So having your installing. So I'm just giving only one box here, but it is technically 4 boxes, 4 different applications, 4 different set of files which you can install and have your middleware or data can be published on top of it and then run your application on top of it and then end users. So this kind of an architecture, we'll call it as a modern data centers. Okay. So if you see what is the difference between my legacy data center and a modern data center, what exactly I'm gaining using this virtualization platform?
Here in the legacy data center, like what are the physical hardware we are assigned to the particular application, there are chances of unused cores, RAM, and there are chances because we are not going to utilize the entire uh, what is the resources at the legacy data center. When it comes to modern data center, we are just evenly allocating the whatever the resources we purchase. We are just evenly distributing and we are utilizing as a whole.
Yeah, so one best thing as you've been mentioned, Chiranjeevi, is that is the effective usage of available compute. You're
Right.
not keeping idle. Whereas
And
legacy
second
data
thing,
center,
it
yeah,
gives an option to switch if any of the VMs need an additional CPU, additional RAM, additional storage. It has the feasibility to switch and share these resources to across the VMs as well.
that's correct. Yeah. On a very basic level, if you could understand here, we are having one application running, right, on a legacy data center in this example, correct? Assume that you are spending, let's say, one application you are running by spending, let's say, $1,000. Okay, using legacy data center. Correct. How many applications you are running? Only one, correct? Here, same with the modern data center. How many applications you can run here? And typically you can run 100 servers also with the 100 applications. One application you are spending $100. 100 applications you are spending $1,000. Sorry, one application for $1,000. 100 different applications for same $1,000. Which one you will choose for your organization if you are the decision maker? You will go with the legacy data centers or modern data centers. Siva, Harsha, able to follow?
Yes.
Yes, yes.
Yeah, we'll go with modern data center.
Here we are getting benefited, right? For the customer, you are saying, boss, where you're spending $1,000 for one application. I can run 1,000 applications, 100 different applications with very well
Legacy,
scalability. Yeah, is there a question?
legacy data centers.
Okay.
Yes.
Shiva, I can't hear you properly. Am I audible?
Yes, yes.
So what is your question?
Legacy data centers
Okay. So in a legacy data centers,
is useful. One application is 1,000.
so I'm just given an example here that here, if you see one physical hardware compute, we have 128 cores of a CPU, 512 GB of a RAM, we have a physical hardware, and you are running only one application on top of it, one OS typically, correct?
Yes, yes.
It means when you're saying one OS, you can run hardly one application. So I will just give an example that assume that you have purchased this hardware and you are spending $1,000, let's say, for running one single application, same hardware only with the virtualization technology, it is allowing you to run 100 applications for same spend of $1,000. You got the point here, Shiva.
Yes, yes, yes.
So that what will happen? Your customer or your business owner will obviously choose this approach only. So if you see before, like it definitely Chiranjeevi might have definitely came across these terminologies and technologies that 2008 and before 2010, what is the heart in the market when it comes to infrastructure? The virtualization only, VMware administrator roles, Citrix administrator roles, right? Hyper-V administrator roles are very good at market because everybody is adopting these virtualization technologies. Everyone requires resources. Am I correct, Chiranjeevi?
That's right.
Right? So now this is a whole lot of picture how the currently data centers are functioning. Okay. Shall we move ahead with a different concept now to understand why I was been speaking all these layers? Yeah.
Okay. Yeah.
Now, what I will do now, we four of us thought of starting a new company today. We decided that we have an application to launch, right, to the business, and we decided to run our own application to deliver to the end user so that we'll get money out of it. Now with this thing to launch one application to the enterprise world, now let's make it as we all four of us want to start a company. What are all the things we required? Right? Shall we get started and see the list of items and understand where
Okay.
exactly we stand?
Yeah.
Yeah, okay.
Okay. The first thing, what you need, and the first thing as we thought of starting a company and we want to run an application. So what we need typically, so let's say I'm coming from a top RL. So I'm an end user, correct? End user where he will get a service, he will get a service from application where this application will run on a middleware or data is required to run or data is needed to run where this middleware or data will host on top of a
Operating system.
software which you install, correct? If it is a web-based application, you can install Apache. On Linux, if it's a Windows machine, you will install an IaaS, Internet Information Services. To run this or install this softwares, what you should have? You should have a operating system, correct? This operating system can be a Windows, it can be a Linux. So when I say the Linux, it will can be a Ubuntu, CentOS, Red Hat, SUSE, you name it, anything Debian. All these things will fall under the Linux operating systems. So with the modern data center where this operating system will be running on a virtualization layer. Am I correct? And if you
Yeah.
are taking VMware, we it can be VMware. If you have Microsoft product, it is in Hyper-V. If it's a Citrix, we have Xanaps and all that stuff. To run this, to configure this virtualization, what you need, we should have a physical hardware, correct? Till now, able to follow, guys?
Yes.
Typical hardware is required. So this hardware can be any vendor, HP or a Dell, right? Like that, or an IBM. So this vendor can be anyone. And then to store your data, what we need physical storage we need, correct? And other thing, physical network switch to communicate with other servers in the data center as well as to communicate with outside world. So when I'm saying the communication, how you will communicate? Now I'm communicating with three of you over the teams. What I need to communicate? Very basic thing. I should have a internet, correct? When I say the internet, it can be your Airtel, Geo, Vodafone, BSNL. These are all like providers for us, like TCL. These are providers for internet services, right? So where you can keep all these workloads, these physical boxes to, we need somewhere to be kept, right? Where we will keep,
Data center.
Asha? Data center. So that is nothing but you need some physical
Right.
space, right? We need to take out some kind of a rent for a single room. Right? This is nothing but a data center. we need to share the amount and then pay for it, correct? As we are the owners for the company. And then, as I mentioned, what is required to run your hardware? Air conditioning, correct? For air conditioning, we cannot run the show because your physical hardware, it is designed in a way that, right, to run this, you should have a air conditioning in place. If it is not meeting up the temperature, your physical hardware automatically initiates its shutdown mode. That is how it behaves. It will tolerate till certain level of a temperature. If it is exceeding, your hardware will go and shut down automatically. Clear, guys? And then very
Yes.
basic thing to run this, what we need a power. Correct? These are the very basic things we need.
Yeah.
So to manage, when it comes to power, it is an enterprise application. When the power goes down, if the application goes down, are we going to lose the business or not? So for that, what I will do typically, I will take service from two different service provider. Let's say one, if I take a connection from a transformer, other I can take and believe it, other source I can depend it on generator. So who will takes care of this power related stuff? We can take care of them, or we need a separate engineer, right? Electrical or a technician we need, correct? Electrical engineer. We cannot do his work, correct? Who will takes care of air conditioning here? Will be taken care by AC engineer. Physical space. This is where your maintenance. We need a maintenance people, correct? It is not like once we purchase and then leave it, correct? We need a maintenance people to clean the stuff. Internet again will be taken from two different sources, kind of a broadband service provider. Your network engineers is fair enough to manage this internet network engineers. Typically, when it comes to typical network switches, again, it is network engineers. Storage to manage who you need, storage administrator. For your physical hardware to manage, again, you need data center admin. So he is expertise in managing this physical hardware. Virtualization platform is a VMware we purchase. We need a VMware admin. Right? If it is Windows, your operating system is running on a Windows, you need Windows admin. If not, it's Linux and Linux admin. Because we don't know how to install and manage the stuff in a server operating system. We have a dependency, separate roles in the organization, right? So you just been mentioned that if you see JBoss admin, WebLogic administrator, Apache Tomcat administrator, what typically they do? They typically manages the website. Here in this, let's say Apache or IIS admin we need to run my website. To get the data, we need a developers. And then as a release engineers, we'll deploy the developers code into an application. And then you are getting and you are releasing the application to end users. This is very basic things I just want to give you. This is not a technology, right? Now you got an idea, like we have been simply using a Facebook or Instagram or Twitter when it comes to Google as an application. Now you realized what is the efforts, what is the number of layers, what is the number of people are typically been working in the background to give one application as a service to the end users. Till now it's clear, folks. Any
Yes.
questions?
No from my side.
How about you, Shiva
Okay.
and Harsha? Able to follow what I'm trying to say? Okay. So now these many things, we four of us want to start a business. So first in place, do we need to invest very basic things in this scenario, correct? All physical things we need to procure, purchase, take out the rent, pay the salaries right from the day one to your rent to your physical space, air conditioning to AC engineer, electrician, network engineer, storage admin, data center admin, VMware admin, Windows admin, Linux admin. This is a very basic thing you need to purchase, and as well as you need to start giving the salaries from the day one to your engineers. Okay, is it clear? To mitigate this limitation are investing a capital expenditure, right? They will call it in technical terminology capex, right? When it comes to billing and costing, right? Chiranjeev, you might have heard of this name called capex with your experience, right? Capex in the sense it's a capital expenditure, right? To start or to onboard any service or an application, what is the amount we have been investing? That is our capital expenditure. So this is all the expenses. We don't know whether the application we for thought to onboard to the enterprise world, whether that is going to accept, that is going to give us returns. We don't know. Correct. There is some vision. We four of us start to have a business, but we don't know that that is gonna click. That is gonna give us some kind of a revenue to us to survive. Correct. But before that, we need to spend our huge amount on this all the each and every layer. You need to spend money. You need to onboard the resources. If it's 24/7, you need multiple people to handle. We need to pay the salaries for all the engineers. Till now, it's clear, folks.
Yes, yes, Rohan.
Yeah. Now, so this is where cloud comes into the picture. Cloud is nothing but it is not something on a cloud. We have the things. It is typically all these layers, whatever you are saying, 1 to 14, it is completely taken care by the cloud vendors. If it's an Amazon, AWS, Amazon will take care. If it's an Azure, Microsoft will be taken care. If it's a GCP, Google as a company will be taken care. All these layers for us, and they will give you whatever we need as a service. For that, you don't need to put any kind of an investment. You just go and subscribe for a service, use it for an hour. If you're not willing to proceed further, you delete the server or a service. You just pay the amount only for that particular 1 hour. Let's say for a 1 hour, your billing is $100, but without having a cloud as a solution, you will be spending 1 lakh USD dollars to run or to check the application, but the same application can be tested by spending hardly $10 per hour. Which solution you will be go and opt? Cloud or data center solutions?
Cloud solution.
So now you got fair bit of an understanding why the cloud is taking over the data center solutions. Yeah. Let me give you this one slider of an information, and then we'll continue from tomorrow. So if you see here as an on-premises, so when I say the on-premises in the sense, whatever I mentioned in this notepad, right? Everything will be holding by ourselves. Ourselves in the sense, in a scenario of projects is owning from the top to bottom. All the layers will be owning by your project team will be holding this, so that what will happen? Entire things will be in our control and we will manage on all the layers. That environment, technical terminology, we'll call it as an on-premises. It means right from the application to the networking or data center, everything. So I didn't mention it here, but what are we discussed in a notepad just before, everything if we are handling, we'll call it as an on-premises environment. On-premises is nothing but your data center. Clear, guys, with the terminology, what is mean by on-premises?
Yeah, yeah.
Next, this is what we have a cloud models. First model is infrastructure as a service. So what does typically do in this infrastructure as service, right? Till the virtualization layer, right from the data center, networking, storage, servers, physical hardware, and a virtualization layer will be completely taken care by Microsoft. In this scenario, we are discussing as a Azure as a platform. So I mentioned as a Microsoft, it's an Amazon or GCP, that vendors will be taken care. It's irrespective of a cloud I'm seeing, right? Our responsibility is just create a virtual machine, install the middlewares or runtime software which is needed, get the data, run the application. We are nowhere concerned about all these layers. This completely, this till 7 to 14 will be completely handling by who? Will be completely taken care by your cloud vendors. You will be responsible from where? Creating a virtual machine based on the CPU and memory which you needed. Run your applications, middleware, get the data from a developers, run the application. Right? You are nowhere concerned about where it is, who is handling. That is completely taken care by your vendor, cloud vendor. In this scenario, who is your vendor? As we are discussing from Microsoft solution, it is cloud vendor is Azure, owning by Microsoft. Is it clear, guys? What is mean by infrastructure as service? Till virtualization layer will be taken care by cloud vendor. From operating system to application layer will be holding by ourselves. Assume that V4 doesn't know how to log into a server, how to install a runtime, where doesn't have an expertise in managing the server operating systems like Linux, like a Windows. I don't have an expertise or you don't have an expertise, but we know how to develop a code, how to run the application. So for such cases, we have an other model that is platform as a service. So what typically we'll do in this solution? Apart from virtualization, on a backend operating system, middleware and runtime install and configure and manages by Microsoft completely. As assume that I'm a developer, I will just develop my code, opt for platform as service, just use the data, deploy the code and run the service. How easy is that? Right? These kind of services will call as a platform as a service. Clear? Next thing is software as service. Whereas assume that I don't want to develop an application. I don't want to run my application, but I want to use the application. In such cases, we have a software as a service. It means from the top to bottom, it will be handling by your product vendor. It can be a Microsoft, it can be a Google, it can be an Amazon, it can be an Oracle, right? All these products, right, will completely, all the layers will be handling by your vendors. You will just go and pay for license cost and then use it. That's it. You will not develop the data. You will not deploy the data. You will not manage the server. But at the end of the day, you will use the application. That is nothing but software as a service. In a shortcut, SaaS products. What are the best example, guys? Today in your company, if you are using O365 email boxes, right? Web emails, Outlook. Those mailboxes is owning by your own organizations? No, right? Typically, you are getting those licenses from Microsoft. One more best example to easily get understand. All of you guys have a Gmails today. Everyone have a Gmail.
Yes.
Yeah. Are we managing Gmail servers? Are we managing Gmail data center? Are we managing Gmail storage? Gmail application? Front-end web application? Who is managing?
Google is managing it.
Google is managing. And we are an end user, we're just subscribing and use it. Correct? The subscribing and using, right? Those all these products, right? We'll call them as a software as a service. Best example is your Facebook today, Twitter. Are we created the Facebook? Are we deployed the code for a Facebook? No. But as an end user, you will just subscribe and make use of those solutions. It is a commercial products, it can be free products, it doesn't matter. We'll call them as a software as a service. These are all the three different cloud models: infrastructure as a service, platform as a service, as well as software as a service. Is it clear, folks? Any questions so far?
No.
Okay, that sounds great. Tomorrow again, I will do the reiterating, rediscussing about this cloud model so that could give you some more amount of a confidence. Yeah, I'm sure that you might have some questions, right? If you have any questions, feel free to discuss.
Yeah, sure.
Harsha and Shiva, any questions?
No.
Able to follow?
Yes.
Okay, that sounds really great. If there is no further questions, let's wind up the session for today and we'll connect back to tomorrow, same time.
Surendra, I have a question here. Like,
Yes, please.
once after the completion of this course, how we can see ourselves? Like, we just want to know what is whatever the topics we are covering here, right? To the end of the course, how we can see ourselves, like, see
So
when.
by default, how you can see ourselves as completely kind of an administrator level, everything will be covered. Based on our own exposure, we can enhance that as an architect and as well as designing the solutions for the customers.
Okay,
That is our approach.
basically we are covering all the administrative, stuff relating to Azure Cloud, right?
Yeah, not only administrator, for a developer components, we're going to cover an authentication part we're going to cover.
Okay.
As a developers is in your company, your own developers are developing an application and they want to use an authentication,
Mhm.
right? So that part's also an Active Directory concept in Azure AD we're going to cover. We're going to
Okay.
touch base on everything so that it does give some kind of an understanding, right? That is the main agenda.
Okay, wonderful. Thank you. Got it.
Yeah, I will share the course content also in a SharePoint. Nothing to
Sure.
worry.
Yeah.
Yeah, I thought of sharing in this session only, but yeah, tomorrow we hopefully we have a larger audience. Let's get discussed all the course content as well. So whatever we discussed till today is not belongs to Azure. It's a very generic concept. Nothing
Right.
we discuss in a cloud with respect to Azure.
And again, tomorrow we're connecting at the same time, or is there any change in the timing?
It will be the same time for now.
Same time. Okay, fine. Thank you.
It will be the same time from 9 p.m. all the time. Until
Okay.
unless if I stuck with something and I will let you know. But for now, this could be the timing.
Okay. Thank you.
Yep. Thank you guys. Thanks for joining. See you tomorrow, same time. Have a good night.
Yeah, thanks. Bye. Good night.